Yeah, good evening to all. Welcome back. So we'll discuss the next conversion, that is hexadecimal to decimal conversion. Okay, so hexadecimal to decimal conversion. Okay, right. So first we'll solve this mathematically, then we convert that into a program. Right. So we'll take an example. Okay. So say for example, we have same hexadecimal number. Okay. So 4C hexadecimal number. It's equivalent to decimal number we need to find out. Okay. So we said from any number system to decimal number system. Okay. So we need to multiply each digit from right to left with the increase in powers of a base of that system. Yes or no? Okay, right? So that means in this case, we need to multiply each digit from right to left with the 16 powers of a 16 here. Okay, so I write these two digits C here, 4 and a C. Okay, so starting from right to left. So this you multiply C, you multiply with the 16 power 0 and 4 you multiply with the 16 power. If we have next digit, that should be multiplied with 16 power 2, 16 power 3, 16 power 4. Like this, we need to increase the power from right to left. Okay, so if we do this calculation, what happens? This is nothing but 4 into 16 power 1 plus C. What is the value of C here? C value is 12. Okay, so 12 into 16 power 0. Okay, so 4 into 16 power 1 is 16 4s are 64. This is plus 12, 16 power 0 is 1. 12 ones are 12. Okay, so this is nothing but 76 base 10. 76 base 10. So 46 in the hexadecimal, its equivalent decimal number is 76. 76. Okay, so here you cannot implement the same logic as we did. We can implement. Okay, only thing is we need to store this in a character array. We need to store the hexadecimal number as a string. That is the only change. In previous programs, conversion to octal to decimal, directly we stored the number. Okay, but here hexadecimal number contains both alpha numeral characters. We need to store it as a string here. Okay, is it clear? Right. Now we'll convert the same mathematical operations into programming logic. Now, kindly write along with me. Okay, so start writing the program along with me. I'll just write here. So include the header file. Include the header file stdio.h. Okay, so then write the main function main. Okay, so here you need to store hexadecimal number as a character array. So you define an array of a size some 100. Okay, so then we need a equivalent decimal number. So dn you define, then reminder here we are not required because each number in array you need to read character by character. Yes, sir. Okay, right. Then we require a loop control variable I. Okay, so what is I value? We'll see afterwards. And the length of the array we need to find out because you need to read the character starting from right to left. Okay, so string length you need to calculate. You declare a variable n here. Okay, so first ask the user to enter a hexadecimal number. Okay, so enter a hexadecimal number. Hexadecimal number. Okay, right? So read the number. How to read the number? You can use, because it doesn't contain any spaces, no? So you can use scanf function with the which format specifier? Can anyone? What format specifier I should use? How can I read hexadecimal number? Yeah, quickly, friends. Not getting any message. How I declared variable hn. So what format specifier I have to use? I'm reading this hexadecimal number as a LD. LD. Are you see hexadecimal number? I told hexadecimal number contains both alphabets and numerals numbers. It is a combination of alphabets and numbers. Okay, so that's why you need to store it as a string. I said I declared a character array, no? So you have to read it as a string. What is the format specifier for reading the string? Reading the string, not characters. Entire string I have to read. Enter a number means he enters 4C. In one go, I have to read this 4C. Okay, so what is the format specifier for a string? Reading a string? Percentage yes. Okay, percentage yes, comma. Okay, so hn, since hn is a string variable, no need of using any ampersand address symbol there. Okay, now this reads the string 4C into the variable hn. Okay, so now because we do not know how many uh, digits he has entered in the hexadecimal number. Okay, so what we need to do? We need to, what is the logic to be implemented in program? Mathematically we did this, okay, but when it comes to program, you have to just slightly change the logic. Okay, so let us just discuss the logic. What is the logic to be implemented in the program? Yeah, so just see here, this is our array hn. Okay, so when I say enter 4C, I enter and it will be stored in array in this format /0. Okay, all are characters. This is 0, this is 1, and this is a 2. So what you need to do? You have to, this is the first character. You need to multiply with the 16 power of 0. Then this is the second character. You need to multiply with the 16 power of 1. Next character, if it's that means you need to read the characters in the array from right to left. Okay, so that means you need to find out string length here. Okay, when you find string length, then you can go to the last character easily, and you can even work out implementing the logic starting from the first character onwards. Okay, so that also I'll tell you. First, let us directly implement the same mathematical kind of conversion into program. Okay, so that is nothing but reading from the last character to first character. Okay, so finding the string length here, say n is equals to string length of hn. Okay, so when I say string length of hn, I need to include string header file here. So include the string dot h header file, string dot h. Okay, so this gives 2. Okay, but where is the last character? This gives 2. Okay, so n, or I can use the same notation length. Okay, so that you can remember this variable easily. Okay, so immediately what I said, you say length minus minus. Okay, so reduce the length value, then length value will become 1 here. Okay, so if I draw memory diagram for this variable length, okay, so when I say length is equal to string length of hn, it gives 2. It gives 2. 2 will be stored. When I say length minus minus, now length will contain a 1. Okay, which is nothing but the position or index of a last character. Okay, that's how we are storing the index of last character. Okay, now you got the last character index. Okay, right. Now using a for loop, read character by character until you reach a 0th character. Okay, so I'm using a for loop here. I'm using a for loop here. So for, okay, so for say int, already I we declare no, so I use I here. Okay, so for I is equals to, what is that? Length. For I is equals to length I greater than or equals to 0. I greater than or equals to 0. Then say I minus minus, because I have to come to 0th provision. From right to left I need to traverse the array. Okay, right. Now, so how can I get the first character here? How can I get the first character here? C, I need to get. Okay, so get the first character here. So declare a character variable here. Okay, right. So where is the first character? I'll directly come here. Where is the first character? Hn of I. The first character is in Hn of I. Yes or no? Okay. Whenever I say Hn of I, this gives this character. C I'll get here. Okay. So better you declare a character variable here, ch. Okay. So read the character. I'm reading the character. Okay. So I'm making the logic simple. Afterwards, say ch is equals to hn of I. Ch is equals to hn of I. Okay, so what is I value? What is I value? We'll go with the memory diagram. This is my variable I. I is equal to length. Length is equal to how much? 1. 1. Okay, so hn of 1. Hn of 1 is what? C. Okay, that C will be stored in a character variable ch. Okay, so which stores? Now capital C is stored here. Okay, so I do not know whether I have received a character or I have received a digit. Okay, so based on that, I need to work out the logic. If I received a character, then I have to convert this into equivalent number. Capital A, if I receive, then I have to convert that into, 10, so that I can multiply with the powers of 16. Yes or no? See here. C means I converted that into 12, then I multiplied with the 16 power 0. Okay, so that logic you have to check here. Okay, so once you get the character, you check whether your character is a digit or an alphabet. Okay, so I am checking here. If it is a digit, first we'll check here. Okay, so if ch is greater than or equals to 0, but this time see here, this 0 is a stored as a character, so you have to include in a single quote. Okay, and ch is less than or equals to the character 9. Character 9. Okay, so that is nothing but you are getting a digit. Now you convert that into digit. Okay, so say for example, when I say this 4 internally, how this 4 is stored? Internally, how this 4 is stored when I say character 4? Now I got the character 4. Okay, so character 4 I got, for example, assume just, okay. So it will be stored as a character 4. Character 4 means what is its ASCII value? Just see the ASCII chart. What is its ASCII value? 4 ASCII value is 52. 0 ASCII value is 48. No? Okay. So 4 ASCII value is 52. So that means internally it will be stored. Internally it will be stored as a 52. Okay. So I want to get the number 4 here so that I can multiply with the 16 powers. I can multiply with the 16 powers. Okay. So how can I get this? If I subtract character 0 from this. Okay, so that is nothing but character 0 ASCII value is 45, 48. Okay, so if I subtract, then I get the result as a 4, which is nothing but the number, Okay, so now this we need to get here. Okay, so if ch is a number between 0 to 9, you convert that into a number. Okay, so how can I convert that into a number? How can I convert that into a number? So I declare a variable something like k here. Okay, so k I am declaring here. Okay, so I say k is equals to k is equals to. Okay, so what I can say, ch minus 0, ch minus the character 0. Subtract character 0 from that, then you will get the equivalent number. 4 I will get. 4 I will get. Hope you understood the logic here. Okay, so ch minus character 0, you can say. Ch is a character minus 0 character. If I subtract, 52 minus 48 will be performed internally and the result will be 4 that I am storing into a long integer variable k here. Okay, right. Now, what we need to do, we'll think of afterwards. Else if it is a alphabet, okay, so then we'll think of what we need to do. Okay, if else if else if. Okay, so what kind of alphabet we will get here? A to F. In between A to F we will get here. Okay, so if CH is greater than or equal to capital A, CH is greater than or equal to capital A, and CH is less than or equal to capital F. You may get any character in between A to F. Okay, so if you get A to F character, okay, so what happens? For example, you got the character in CH, you got the character C you got. Okay, so in CH you got the character C. Okay, but this C has to be converted into the number 12. This C has to be converted into the number 12. It has to be converted into number 12. How we can do that? Okay, so I got the character C. That means internally how it is stored. Internally how it is stored, character C means 65 is capital A, 66, 67. That means internally it is stored as a 67. Internally it is stored as a 67. Okay, so if you subtract this capital A, if you subtract from this, nothing but you are subtracting a 65 from this. You are subtracting a 65 from this. What is the result you will get? That means it is 2 characters away from capital A. 2 characters away from capital A. Okay, so you have to subtract a capital A. Then if you add 10 to this, you will get 12. Okay, so then add 10 to this. Then you will get the number 12. Now this logic applies to any other character. For example, you take some other character. Assume that you got the character as a E. You got the character as a E. Okay. So what is E internally? How E will be stored? ASCII value of E. If you see ASCII value of E, I show. Okay. So capital E ASCII value. Where is it? Capital E ASCII value 69. Okay. Right. Capital E ASCII value is 69. Now what I am doing here, I am subtracting the character A, nothing but whose ASCII value is 65, I am subtracting. Okay, so result I will get 4 here. Then I am adding 10 to this. I am adding 10 to this. Okay, so what I will get 14. So capital E is nothing but 14 or not? Yes. Okay, so what I am trying to do here, just understand the logic here. Whenever I get a capital C, okay, so I am converting that into the number 12. Whenever I get capital E, I am converting that into the number 14 so that I can multiply this with the powers of 16. Okay, right. So how to do this in the programming? Just see here. So now what I do, I'll just implement the same logic here. Okay, so if ch contains a character A to F in between. Okay, so now what I have to do, I have to say ch minus capital A, ch minus capital A. Okay, so then plus 10 I have to add, then plus 10 I have to add, then that will be converted into a number. Okay, so then that I will catch into the variable k here. Okay, so k is equals to Then say k is equals to, yes, any doubt? K is equal to ch minus capital A plus 10. Okay, good, Abhinav. Right, this is okay. So when we ask the user to enter a hexadecimal number, he may use lowercase letters sometimes. Okay, he may use lowercase letters. Okay, so in such case, we need to handle that also. Okay, so that means you need to check whether it is lowercase a to f or not. So what I do, I just copy paste this code here so that, yeah. So if it is not a number, it is not a uppercase. Okay, so if it is a lowercase, that means small a to small f, small a to small f. Okay, so simple, same is the logic. From that character, subtract small a, then add 10. Subtract small a, then add 10. What happened? Just see here. For example, I got the character as a something like small b. I got small b. I got. What is its ASCII value? Just see here. 97 means 98. Sorry, 60. 97. Okay, see here. This is decimal value. Small a ASCII value is 97. Okay, so small b means how it will be stored. Small b means how it will be stored. It will be stored as a 98. So I am subtracting a small a from this. Small a from this. That means I am subtracting 97 from this. Okay, so what I will get? 1 I will get. Then I am adding 10. Then what is the result? I will get 11. So small b is nothing but 11. Yes or no? Small b value is 11. Capital B or small b, it is 11 only. Okay, so the same logic works here. Okay, so then I get equivalent number in this. Then I get equivalent number. Okay, so I am converting the character into number. Okay, so once I get the number, what I need to do? What I need to do? That means assume that 12. Okay, so 12 value I got in K. 12 value I got in a K. Okay, so what I have to do? I have to multiply this 16 power 0. I have to multiply this 16 power 0. Okay, so for that I told you we can use a multiplier. We can use a variable called as a multiplier. Okay, so say multiplier. Multiplier is equal to 1. Okay, so 1, 16, 32. Okay, so sorry, 60. 16 power 1, 16 power 2 means 256. Okay, so that means every time you double the number with a 16. So initially it is 16 power 0 means 1, then next 16, then next 256. Like this, we increment the multiplier value. Okay, so now I got 12 here. So now I need to convert that multiply 12 with a 16 power 0. Okay, so it is nothing but now I'm doing that calculation. Just see here. This is conversion. Okay, so K multiplied by multiplier. Okay, so 16 power 0 I am doing multiplier. Okay, so this I have to add where? I have to add it to decimal number. Okay, so then I say decimal number plus is equal to decimal number plus is equal to. So initially you should declare decimal number is equal to 0. So initially you say the decimal number is equal to 0, you should say. Okay. So then what it will do here? 12 multiplied by 1. 12 ones are 12. Okay. So the 12 plus 0 will be 12. That will be stored in a DN. Okay. So now I draw the diagram for this. So DN now stores a 12. DN now stores a 12. Okay. So afterwards, what you need to do? You need to change the multiplier. Yes or no? Okay, so multiplier you need to change. Now you say multiplier is equal to multiplier. Okay, so multiplier star is equal to 16. That means every time you multiply with a 16. Okay, so then close this for loop here. Now for loop ends here. Multiplier will become 16 here. 1 into 16 is 16. Okay, so this is the multiplier value. Previously it was 1. Okay, so I'm just showing this as mul here. Multiplier value 1 into 16 means 16. Okay, so end of the loop reaches here. Then it goes to increment section. I minus minus. I minus minus means I value will become 0. Okay, so I value will become 0 here. Okay, so I value becomes 0. CH is equal to HN of 0. HN of 0 contains what? 4. Okay, so that 4 will be stored here. Okay, now see here. 4 will be stored here. 4 character we obtain here. Okay, so now see here. CH greater than 0 and less than n. Is it a digit? Yes. Now it is CH minus 0. Okay, so 4 means 52 minus 48. 52 minus 48 means you will get the number 4 here. You will get the number 4, and this LC is not executed. Directly control comes here. Okay, dn is equal to dn plus k into multiplier. What is k value? 4 here. Okay, so what is k value? 4 we got. 4 into multiplier value is 16. Okay, nothing but 16 power 1 you are multiplying. 16 4 is 64. 64 plus dn value. Okay, so 64 plus dn value is 12. So okay, 4 2 is 6 here. 6 plus 1 7. 76. Again we are catching in dn. Nothing but dn will now contain a 76. Then multiplier is equal to into 16. So this will become 256. This will become 256. 16 power 2. End of the loop reaches. Okay, so then I minus minus I will become minus 1. 0 minus 1 greater than 0 false. Then comes out from the loop. Comes out from the loop. Okay, so where is our equivalent decimal number? In a variable called as a dn. Now if you print the dn, that gives equivalent decimal number. Okay, so now we say equivalent decimal number. Okay, so decimal number is equal to, okay, so a percentage LD. Okay, percentage LD, then say comma, where is it? dn. Okay, so close it, then say return 0. That's it. Return 0. Then close the main function. Okay, so this is hexadecimal to decimal conversion. So if you have any doubts, just post your doubt. Meanwhile, I'll copy this into. Did you understand why I'm see adding 10 here? Why I'm adding 10 here? Why I'm subtracting 0 here? Okay, so these logics you should get on the spot. Okay, right. Now just let us cross check whether it gives correct output or not. Okay, so here no need to print anything because we are getting the number directly. So what I do is I open one more online C compiler so that you can cross check from this compiler. In one window we have decimal to hexadecimal program. Okay, so in another window we have hexadecimal to decimal program we are copying. Just copy this here before our. Okay, so we have to format the bottom. This. Okay, then I close this here. Okay, right. So let us run this code. Okay, so I think we have included all required data files. Okay, anyhow, if any mistakes, yeah, enter a hexadecimal number. Thank God, without any errors, it executing. Okay, so this is how you should write the program. Okay, so many syntax errors if you write, then it takes time to correct all those syntax errors. While writing, be careful, very keen about writing each statement. Okay, hexadecimal number. What example we have taken? 76. 74C is the hexadecimal number. Okay, right. So 4C, I enter here. 4C, just see, I entered in lowercase letter. Okay, equivalent to decimal number, something wrong it printed. Okay, so what happened? Just let us look into the code. Okay, so what I have used there, percentage LD comma DN. Okay, so what is happening? Just look into this. I declared DN as a initialized to 0. Okay, so then length also. Okay, I got length minus minus I is equal to length. I greater than or equal to 0, I minus minus CH I got here. It is this. Okay, yes. Dn plus is equal to k into multiplier. Multiplier star is equal to 16. Yes. Multiplier initialized to 0. Yes. Multiplier initialized to 0. No? No. We are not taking powers. We are directly taking those numbers 116 to 56. You know. 1, then next we are making it as 16. Then we are making it as 256. That is how we are doing instead of taking power function. Okay. So then end of this reaches equivalent to decimal number dn. Okay, multiplier. Right. So we'll test here string length. Okay, so just let us cross check. Code is logic wise it is okay. Okay, so let us just check out what value we are getting in length. Okay, so length minus minus, after doing length minus minus, say printf. Just check out length is equals to, okay, say percentage LD comma length. Whether I'm getting this correct or not, let us just check out. So 4C, no, length is equal to 1. Okay, your length value is 1. Anyhow, new line. Then for lowercase letters, is it okay? Yeah, here it is problem. That is what. See here, CH greater than or equal to capital A and CH greater less than or equal to small a. Sorry, small a and less than or equal to also small a I use it. Okay, so here this should be F and it is CH minus small a plus 10. Okay, so because it is checking only up to small a, but I entered C here, small c. So that's why I'm not getting the correct value for this. Some garbage value it is taking. Okay, so now I remove this printf statement. Okay, so let us run the code. Now 4C I enter. Now you can see 76. Okay, so while typing, I copy pasted, no, something I made a mistake there. Okay, so now even we can run this with capital C, I enter, it works or not, you need to cross check. Okay, if it is working, capital C also, it is working. Okay, so previously in another window, we enter some other thing. No, let us just cross check that. Yeah, here. Window is gone. Huh? Right. Okay, so let us run this. Enter a number 10. I'm sorry. 10480 I entered, no? 480 I entered. Okay. So what it has given 28F0. Okay. Or we'll take some other number. Say 10486, I think. 486 we enter. Yeah, 28F6. Okay, 28F6 is the number. In this, we'll check here. Okay, so here we run this code. 28F6. We enter F6. Okay, see 10486. Okay, so this way in two windows, if you open two programs and you can cross check whether your code working fine or not. Right? So any doubts? I can take up doubts for 1 or 2 minutes. Otherwise, then we'll move on to the program which was asked in TCS Ninja August slot 2 based on this logic. Okay, I'll just display that. Now this is the code. Let me just demonstrate to you. Yeah. Any doubts in this? Just have you copied this code and everything? That is coding questions. Yeah, this is the question. This is the question asked in Ninja August 2020 slot 2, I think. Okay, just take the screenshot and now you need to work out the program on this. And by night 10 o'clock, I should get all your programs in our group. Executed code, please remember, executed code. Okay, so what is Sweet 17? And please remember, for every problem, they use some description and they give some heading. They name some, they name the problem with some heading. Okay, so Sweet 17 problem, this is called. Given a maximum of 4 digit to the base 17. Base 17. That means 10 is A, 11 capital B, 12 capital C, 13 capital D. Like this, 16 is capital G as input. Output, it's a decimal value. Example test cases he has given. Case 1 input is 1A, then expected output should be 27. Okay. If input is 23 GF, then expected output should be 10980. 10980. Hope I think now you are in a position to write program for this problem. I expect it. I expect. Am I correct? Can I expect? Yes. So I got one answer, yes. Okay, so you should try on your own.